Now, of course, the Hubble is this thing in space moving thousands and thousands of miles an hour in orbit, and which means its natural tendency is that it's going to be tumbling end over end.
Sometimes it's gratifying to turn our thoughts to space, taking pride in humanity's everyday triumphs and the steady advances of our science. But the Hubble Space Telescope offers an inspiring example of what we can accomplish with data and with a strong team of collaborators. As the telescope celebrated its 30th anniversary in space last year, we are reminded that it's a proud product of careful design, dedicated long-term support, and cross-agency collaboration. Floating just outside the Earth's atmosphere, spying on distant galaxies and our own solar system, it's a joint project of NASA, the European Space Agency, and the Baltimore-based Space Telescope Science Institute. What is the overall goal of the Hubble Space Telescope? How does the Hubble telescope work? And how powerful is this telescope? Before we begin, make sure to smash the like button, subscribe to our channel, and click the notification bell for more amazing videos. The Hubble Space Telescope is a large telescope in space. It was launched into orbit by Space Shuttle Discovery on April 24, 1990. Hubble orbits about 340 miles above Earth. It is the length of a large school bus and weighs as much as 2 adult elephants. Hubble travels about 5 miles per second. That's like traveling from the eastern coast of the United States to the western coast in 10 minutes. Hubble is also solar powered. Hubble takes sharp pictures of objects in the sky, such as planets, stars, and galaxies. Hubble has made more than 1 million observations. These include detailed pictures of the birth and death of stars, galaxies billions of light years away, and comet pieces crashing into Jupiter's atmosphere. Scientists have learned a lot about the universe from these pictures. Many of them are beautiful to look at. Size, length, 43.5 feet or 13.2 meters. Weight at launch, about 24,000 pounds or 10,800 kilograms. Weight post SM4, about 27,000 pounds or 12,200 kilograms. Diameter at widest point, 14 feet or 4.2 meters. NASA named Hubble after American astronomer Edwin P. Hubble, 1889 to 1953. Hubble confirmed an expanding universe, which provided the foundation for the Big Bang Theory. In the beginning, since the dawn of civilization, man was limited by his vision and imagination about his understanding of the universe. The telescope enhanced his vision and tempered his pride, as observations by Copernicus, Galileo, and Kepler in the 16th and 17th centuries AD rebuffed the millennia-old conceit that the Earth is the center of the universe, spearheading the scientific revolution. By the 18th century, the telescope would become the indispensable instrument for investigations of the cosmos. Bigger and better telescopes were built all over the world. Planets, stars, and nebulae, which could not be seen by the naked eye, were now being routinely noted and logged. Advances in spectroscopy, photography, and photometry increased telescope versatility, sensitivity, and discovery power. Enter Edwin Hubble. By the turn of the 20th century, most astronomers believed that the observable universe consisted of one galaxy, our Milky Way galaxy, an oasis of stars, dust, and gas in the vastness of space. However, in 1924, American astronomer Edwin Hubble used the 100-inch Hooker telescope on Mount Wilson near Los Angeles, California, to observe billions of other galaxies besides our own Milky Way, almost all moving away from each other. This suggested that the universe is expanding, unleashing a Pandora's box of seminal inquiries, such as the Big Bang Theory, about the possible beginning and end of the universe, issues which are still being debated today. Astronomers like Edwin Hubble, before and after his time, toiled long, frigid nights in enormous dome-shaped observatories, pointing their telescopes skyward, yearning for the best possible snapshot of the heavens. However, they faced a major obstacle that stood between them and a clear view of the universe: the Earth's atmosphere. The Earth's atmosphere is a fluid, chaotic soup of gas and dust. It blurs visible light, causing stars to twinkle and making it difficult to see faint stars. It hinders or even totally absorbs other wavelengths of light, making observations of such wavelength ranges as infrared, ultraviolet, gamma rays, and X-rays difficult or virtually impossible. It is also these properties which protect us from the harmful effect of these rays. Observatories with the largest telescopes in various continents have been perched upon mountaintops and away from distracting city lights, from Caucasus Mountains in Europe to the Australian outback, with varying levels of success. Adaptive optics and other imaging processing techniques have minimized but not totally eliminated the effects of the atmosphere. Hubble is born. In regards to the maintenance and upgrading of the Space Telescope, plans were made to conduct servicing missions in orbit versus returning the telescope to Earth and refurbishing it on the ground. It was an innovative concept that would have been easier on a budget. In the midst of this spirit of renovation, the Space Telescope was renamed the Hubble Space Telescope, or HST. By 1985, the telescope was assembled and ready for launch. However, in 1986, disaster struck. The Challenger accident forced NASA to ground the Space Shuttle fleet for 2 years. However, these were years well spent by the HST project. Solar panels were improved with new solar cell technology. The aft shroud was modified to make instrument replacement during servicing easier. Computers and communication systems were upgraded. The HST was subjected to further stress tests in the harsh environments of liftoff and space. Finally, on April 24, 1990, the Space Shuttle Discovery lifted off from Earth with the Hubble Space Telescope nestled securely in its bay. The following day, Hubble was released into space, ready to peer into the vast unknown of space, offering mankind a glimpse upon distant, exotic cosmic shores, yet to be described. About 1 month after launch, it became apparent that the HST's large primary mirror had been ground to the wrong shape owing to faulty testing procedures by the mirror's manufacturer. The resulting optical defect, spherical aberration, caused the mirror to produce fuzzy rather than sharp images. The HST also developed problems with its gyroscopes and with its solar power arrays. On December 2nd to 13th, 1993, a mission of the NASA Space Shuttle Endeavour sought to correct the telescope's optical system and other problems. In 5 spacewalks, the shuttle's astronauts replaced the HST's wide-field planetary camera and installed a new device containing 10 tiny mirrors to correct the light paths from the primary to the other 3 scientific instruments. The mission proved an unqualified success, and the HST soon began operating at its full potential, returning spectacular photographs of various cosmic phenomena. 3 subsequent Space Shuttle missions in 1997, 99, and 2002 repaired the HST's gyroscopes and added new instruments, including a near-infrared spectrometer and a wide-field camera. The final Space Shuttle mission to service the HST intended to install a new camera and an ultraviolet spectrograph, and was launched in 2009. Hubble's Instruments. Hubble is a type of telescope known as a Cassegrain reflector. Light hits the telescope's main mirror, or primary mirror. It bounces off the primary mirror and encounters a secondary mirror. The secondary mirror focuses the light through a hole in the center of the primary mirror that leads to the telescope's science instrument. People often mistakenly believe that a telescope's power lies in its ability to magnify objects. Telescopes actually work by collecting more light than the human eye can capture on its own. The larger a telescope's mirror, the more light it can collect, and the better its vision. Hubble's primary mirror is 94.5 inches, or 2.5 meters in diameter. This mirror is small compared to those of current ground-based telescopes, which can be 400 inches or 1,000 centimeters and up. But Hubble's location beyond the atmosphere gives it remarkable clarity. Once the mirror captures the light, Hubble's science instruments work together or individually to provide the observation. Each instrument is designed to examine the universe in a different way. Scientists decided that 5 scientific instruments would initially be included in the HST. These are Wide Field Planetary Camera 1, WFPC-1, Faint Object Camera, FOC, Faint Object Spectrograph, FOS, Goddard High Resolution Spectrograph, GHRS, High Speed Photometer, HSP. The telescope pointing system, made up of fine guidance sensors, FGS, essentially provided a 6th instrument which could be used for measuring angles in the sky. Each instrument had a different purpose and was designed to look at the universe in a different way than the others. This way, different kinds of data could be received and studied. The WFPC-1 is the main camera and takes most of the pictures. It is designed to look at a small portion of the sky, but one can build a mosaic of images to construct a picture of a larger part of the sky. Each servicing mission installed a new and improved WFPC. This is an image of the Eagle Nebula, which contains dark clouds from which stars form. It is in the star cluster M16, also known as NGC 6611. The image was recorded on April 1, 1995, with the Wide Field and Planetary Camera 2, WFPC-2. The WFPC-2 was used to take many famous Hubble pictures. The WFPC-2 was on the telescope from 1993 to 2009. It was removed mid-2009 to make way for the Wide Field Camera 3. It observed just about everything, recording razor-sharp images of faraway objects in relatively broad views. Its 48 filters allowed scientists to study precise wavelengths of light and to sense a range of wavelengths from ultraviolet to near-infrared light. Images taken by Hubble have helped scientists estimate the age and size of the universe. Scientists believe the universe is almost 14 billion years old. Hubble has helped scientists understand how planets and galaxies form. An image called Hubble Ultra Deep Field shows the farthest galaxies ever seen. Hubble has detected black holes, which suck in everything around them, including light. The telescope has played a key role in the discovery of dark energy, a mysterious force that causes the universe to expand faster and faster as time goes on. It has revealed details of gamma-ray bursts, powerful explosions of energy that occur when massive stars collapse. Hubble has also studied the atmosphere of planets revolving around stars similar to Earth's sun. The HST's discoveries have revolutionized astronomy. Observations of Cepheid variables in nearby galaxies allowed the first accurate determination of Hubble's constant, which is the rate of the universe's expansion. The HST photographed young stars with disks that will eventually become planetary systems. The Hubble Deep Field, a photograph of about 1,500 galaxies, revealed galactic evolution over nearly the entire history of the universe. Within the solar system, the HST was also used to discover Hydra and Nix, two moons of the dwarf planet Pluto. The future of Hubble. Hubble turned 30 years old in 2020. Engineers designed Hubble so that it could be repaired and upgraded as needed. Since the Hubble telescope's launch, 5 space shuttle missions have carried astronauts to Hubble to repair and upgrade it. The last mission was in 2009. Hubble was upgraded so that it is better than ever. The telescope will not be repaired or upgraded again, but it is expected to continue to work past 2020. Meanwhile, NASA and its international partners are preparing the James Webb Space Telescope. The Webb is an infrared telescope that will be larger than Hubble and will be able to see through clouds and dust in space. Instead of orbiting Earth, this telescope will orbit the Sun from a point beyond the Moon. Webb will send back amazing images like Hubble does, and it will help astronomers unlock more of the biggest mysteries of the universe. That's it for today's video. Don't forget to smash that like button, share this video with your friends, and tell us what you want to see next in the comments section below.